Okay, good evening, everyone. Today we will learn non-parametric statistics based upon our syllabus with the help of jamovi. Today we will learn the practical part. Theoretical part already discussed by Sneha madam, and today we will learn the practical. And now I am making host Farah for presentation of the slide. Okay, Farah, now you can start.
Okay, sir. So, good evening, students. Today's tactical class focuses on non-parametric statistical tests, which are used when data do not meet the assumption of parametric test. So, in this, we will cover the chi-square test, rank order correlation, Wilcoxon sign rank test, sign test, Mann-Whitney test, and Kruskal-Wallis test. So the first is chi-square test. So in this, you can see that we are using two variables. One is gender, and another one is nationality. Yes, actually there are three variables: gender code, nationality, and education code. And we have to convert this into the gender code. We have to convert this into nominal, and nationality code also we have to convert. Then you can see there is a filter sign also. One second, previous slide. Yeah, there is a filter sign also. So we use filter sign when we do not want to include some of the cases. So this is a formula we use for filter. The cases that we are not using is number 3 category in nationality code, and in education code we are not using number 1 category. So before performing chi-square test, we have to first we have to convert these variables into categorical level. Now this is the analysis part of the jamovi. You have to first click in analysis, and then you will get this thing. And this is the chi-square test in the analysis. Let me show you a movie. Not this comes under frequency, contingency tables, independent samples, test of association. Let me show you the option because in my PPT it's not there. So you go to the analysis, click on frequency, and you will find this independent sample on it. Okay. Now, yes, let me go back to my. So when you click on this, you will find this kind of table where.
Okay, Farah. So
Yes, sir.
now I want to tell. Now, when we are dealing with the chi-square, always we have to assume that chi-square is applicable in case of the frequency data. Okay. And here you can find out the gender. And this gender, we have given the code. Code is 1, 2. Okay. Another one is the education level, and we have given the code, edu code. Now our interest is to find out the relation between gender code and the edu code, does it vary by the nationality? So here nationality means India and Bangladesh. So I have collected this data when I visited Bangladesh. At that time from Dhaka, I collected this data. So here you can find out the association, okay, between gender and edu by the layers. So here you can find out the nationality code. So 2 is there. Okay. Now here uh, the contingency table. so, so you can find out the 2 by 2. Okay. 2 by 2. The contingency table covers the education code and the gender code with respect to the nationality. So this is the uh, frequency, and below you will find the chi-square test. In case of the Indian data, we find there is some association, but in case of the Bangladesh, we do not find any association. That means nationality moderates the relation between the gender and education. And below you will find out the phi coefficient. Phi coefficient is 0.29 in case of the Indian data, and Kramer's B, that indicates the effect. It is 0.29, and in Bangladesh it is 0.20, and the effect is 0.20. Phi coefficient without any nationality, that is 0.23, and Kramer's B also 0.23. So now over to Farah.
Yes, sir. So this is about the chi-square test. So in this test, like sir said, we have performed this thing, and there are these things we have to focus on for interpretation, like nationality code, edu code, gender code, phi coefficient, grammar where we. Now moving to the next test. The next test is rank order correlation. So in rank order correlation, we are taking the same data. This time the gender code we have to this variable we have to change its major type. We have to make it ordinal, and edu code also ordinal. So in the chi-square test it was nominal, but now in this test it is ordinal. So in the gender, you know already there is male and female, and education, there are two categories, uh, graduate and postgraduate. Third category, we are not including, we are using filter for that. So now how to find the result in Jamovi for rank order correlation. So for rank order correlation, we have to go to the, let me show you in Jamovi only where we have to go. 1 second. Yeah, we have to go to regression and click on correlation matrix. Okay, regression and then go to the correlation matrix. Now, let me show you my PPT. So, after this, you have to take gender code here, education code here, and nationality code also you have to include. And then you will find, and you have to click on flag significant correlation and click on Spearman correlation. Okay, and you will get the correlation in the result section. So you will find that the correlation matrix shows that gender code, edu code, and nationality code. Okay. And there's a statistically significant negative correlation was found between gender code and edu code, minus 2.31. Okay. This indicate that
Fine.
gender. Yes,
Hello, Farah. Uh,
yes, sir.
we can deal with the other variable, that is the self-awakening and emotional. I think that is better instead of this gender code and edu code.
Okay, sir. In the correlation, we can use.
Because this is not the, it is
Sure, sure.
the, yeah, I think that is better. If we can correlate between the self-awakening and emotional control, there we
Yes.
can use this
Okay.
instead of the gender code and the edu code, because they are basically the uh, frequency.
Yes.
So if we can study
Yes, sir.
the self-awakening and the another thing, this emotional control,
Yes, sir.
then we can use this one.
Yes, sir. So the result is 0.703.
Uh,
Just if we, yeah, if
and
we
you have
want to,
to click the spearman.
yeah, Pearson. This
Okay,
is
Pada, you
Pearson.
click.
Spare.
So when you click spearman, then you find it is 0.65. So you have to, you click both, Pearson and spearman,
Yes.
both. Yeah, so here you can find out. That is whether the spearman's row and the Pearson's are. Okay, slight difference you have noted.
Yes.
Self-awakening versus emotional control.
Yes, sir.
Uh,
So,
Now you
huh.
go to the next one.
So this is, yeah, yes. So this is how we check correlation metrics in Jamovi. Now I'm moving to the next test. Next is Wilcoxon. So in Wilcoxon, we are using RG editor in Jamovi. We are using hypothetical data. So this is a research question. Suppose the researcher wanted to know whether the new self-esteem measure is reliable and consistent over time. So to test this, 20 participants completed the measure on 2 occasions, 1 week apart. Okay. This is purely hypothetical data. This is first administration data and this is second administration data. So where you have to type this, you have to type this manually. You have, let me show you in Jamovi. So go to the R, you will find this R icon, click on RJ editor and then click on first administration and second administration. So let me, yeah, let me type for you. You can type any data. Mhm. You have to type manually here. After this, how will you check? You will write first administration, second administration, and select all four steps, all the four steps, and just use this green button, click on it. Administration, I think something is wrong. Second administration not found. Okay, there is some spelling mistake. So you have to be very careful in typing RJ editor screen, because if there is a spelling change or something you are changing, then it will not catch. Like first administration जैसा भी लिखा है, you have to write first administration in that way only. So first and second administration, these are considered to be vectors in RJ editor language, in our studio language. So now this is your data. Okay. After this, there will be the second step for it. Second step is rank the score. You have to rank it because it is Wilcoxon signed rank. So the second step is rank the score. You have to write down here. When you're putting hashtag, then this is not a command. This is just you are writing the instruction. Okay. So second step is rank the store scores. So rank first is your vector. Vector is like you are giving name to something, to your file. So rank first, and then rank is your function. Okay. Rank and then bracket first administration, your first vector, because first administrations carries your data. Okay. And you have to do similarly for the second administration. You have to name the second administration rank data, which is rank second, and you have to use rank command and then bracket second administration. Now you will see what it what you will get. So this is rank data. This is for the first administration and this is for the second administration. Now we will, in step 3, we will see Wilcoxon rank subtest. Okay, Wilcoxon. So you have to write down here this thing. And you will find you have to write this Wilcox dot test. Wilcox dot test is your function. So in R, you have to remember the function command. Okay, because it is all depending upon the coding. So Wilcox text is your command, is your function. And then rank first and rank second, these are your names where you are storing your rank data. So in this way, you have to write here. So this is your result.
Okay, now I
And
am telling,
yes, yes,
Pada,
yes,
now I
yes.
am telling. So sometimes we are interested to study the effect of some training program or effect of some intervention, okay, on some behavior. Okay, suppose there is some intervention, maybe the training on uh, maybe the mathematics skill development. Okay, so that is the training. Now, before the training, you have to collect the data. That is the first administration. Okay, related to the mathematics achievement test. And after the training, Again, you have presented the same mathematics achievement test. Okay. So this is the first administration and this is the second administration. Now, when we are using Jamovi, one advantage is the RJ editor. Sometimes we cannot solve all the problems by using the menu of Jamovi. At that time, we can use the RJ editor. Hmm. So here you will find that this is the continuous data 20, 18, 23, 16. This is the continuous, this is the score. And we have modified the score into rank. So rank is the function. So this is the first administration and rank is the function. When we are writing the rank as the function, there you can find out the rank. Okay. And if there is any paired value, that is also extracted through this rank. Okay, so rank first and rank second. After that, what Farah has told you, that is the Wilcox dot test. When you have written Wilcox dot test, then you will get the rank first and rank second, whatever the association is there. We have noted that there is no significant effect. Okay. That means whatever the training we have given, it has no effect. So alternative hypothesis, true location shift is not equal to 0. Okay, now over to Farah.
So now we will move on to the second test. Second, another test is sign test. So sign test maybe also we are using hypothetical data. And in this time, the hypothetical question is that the researcher wanted to investigate whether a new therapy for depression is effective. To test this, 10 participants diagnosed with depression completed a standard depression questionnaire before and after the therapy. Okay. Now I'll show you all of this in Jump. So now I'm just erasing this thing because this was for Will person. Clicking again, click. You have to go to the RJ editor. Click RJ editor. Then this window will open. And first step is you have to write down your hypothetical data. So we right now I'm just typing before and after therapy data. It is purely hypothetical. So this is my hypothetical data before therapy and after therapy. Same before, this is the data, and after, this is the data. Now let me run this. This is your data. Okay. Now next step is you have to make a data frame. So in data frame, what you are doing actually, let me show you first. So depression is just like you are giving a name. Okay. Name in new folder. You create new folder in your computer. So this depression is your new folder equal to data frame. Now data frame is a function. So when you write data dot frame and bracket you type before and after, that means in that new folder file you are adding more files. Okay. So this before data you are adding in this depression file, and after data you are adding in this depression file. And how will you will add it? You will use the data dot frame function. Okay, now let me check. How will you check? You will have to write down depression again, and you will find that your before and after data is in one folder now. It is not separately written. Okay. After this, the step 2, calculate the differences. Okay. Now we'll see the difference. The step 2. So depression dollar is also a file name. I've just made it little complicated. You can make it anything. So now, because there is a depression in the depression file, there is before data and after data. So dollar sign. So when you want to check what is there in the file, you have to use the dollar sign. When you use dollar sign, you will find what is all there in depression. So what is there in the depression? Before data and after data. So now I'm taking, because I have to find out the difference, so I'm taking first before data, dollar before data, minus depression dollar after data, and then I'll get the difference. So this is the difference. This is the, because this is a sign test, so this is the difference. You will see positive data and negative data, negative values and positive values. Okay. Now the final step will come, and that is performing the sign test. Okay. So for performing the sign test, we have to use the function binom dot test. Okay. And here you will find some depression dollar difference is your file name, where you have, where you are minus where just you are subtracting before say after data, and length, how much depression or difference ka length kitna hai. So 10 participants were there. P equal to 0.5, alternative 2 equal to two sided. Okay. Now when you click on this, you have to remember this thing. Otherwise you will unable to perform the sign test, because there are some functions in our studio, and there are some vectors which we call in layman language files name. Okay, so this is the function. So for this function, you have to remember all your file names. This is your file name, this is also your file name, and these are the functions like sum, length, p equal to 0.5. You are restricting. Okay. Alternative, this two sided also. You are, you are restricting this thing. So this is the result. So with this result, what are we getting? What it is? What is the interpretation? Is it significant? It is significant. Okay. The sign test was conducted to examine whether the new therapy for depression had a significant effect on participant depression. Out of 10, 10
Para
participants,
p value
okay.
is zero point
P1,
0.1. It
yeah,
is
yeah.
not significant.
The question was whether it is significant or not. Yeah, that's right, sir. So
So
out of
this is not significant. Huh?
this is not significant. Concluding, so the question was whether it is significant or not. So it is not significant, because out of 10 participants, 8 showed an increase in his scores, and baki others, though, like, it is not significant. So the new therapy for depression is not effective. So because this was a hypothetical data, so the result is like that. Now the next test is Mann Whitney U test. Let me show you the P first. in this also, we are using hypothetical data. And this time, the researcher wanted to investigate whether age is associated with social anxiety or not. And to test this, 25 participants in a younger group and 25 participants in an older group completed a standard social anxiety questionnaire. Okay. So this time, what we have done, we have not used R Studio. We have manually put the hypothetical data in Jamovi. So let me show you. So this is how we have done. This is the variables. So group is younger. In group, you will find two groups. One is younger group and one is older group. So in this way, you have to add the data. It is just like adding the data in Excel file. This is your score data. This is for the younger group data and this is for the older group data. Okay. Suppose you want to, let me show you how to add it. Suppose this data I want to add in other columns. So how will we add? We'll add like this. Okay. Now C and D, how will we write? We have to go to the variables, click on C, edit. This is your group, write group here. Okay. This is your ordinal data. And then this is your score. So write down score here. This is your continuous. Now, how will you perform Mann-Whitney U-test? So you have to go to the independent sample t-test. Analysis, click on analysis, go to the t-test, click on independent sample t-test. You will find here Mann-Whitney U. Okay. So in this, you have to add score independent and group in grouping. Okay. So this is your result. This is your Mann-Whitney. Oh, sorry. Click on Mann-Whitney and then you will find the Mann-Whitney result. So this is how you will check the Mann-Whitney U test in jamovi. Okay. The function is clearly there. I mean, you don't need to use RJ editor for this. You have to go to the t-test, click on independent sample t-test, add the continuous variable independent variable and the ordinal variable in the grouping variable and click on Mann-Whitney test. Okay. So the result shows that the older group has higher social anxiety than the younger group. Okay. This is your Mann-Whitney test.
Father, you click the mean difference.
Yes.
Acha, mean difference is not applicable, na? No.
Yes, sir. Only the Mann-Whitney.
Mann-Whitney test.
Yes, sir. Mann-Whitney is statistics 17.5 P is
Yeah,
0.
yeah. Mhm.
So older, younger, this you can see. Note is given. So older group has more anxiety than the younger group. Okay. This is also hypothetical data. Now we will see the last test. Let me go to the PPT. Last test is Kruskal-Wallis test. So in the Kruskal-Wallis test, we are using our own data, like for value data. So value data may you will see that we are using one. There you will find a ANOVA function. When you click on analysis, you will find ANOVA. So you click on ANOVA and you take one way ANOVA and you will see Kruskal-Wallis test is also mentioned in that one way ANOVA. Let me show you. Let me show you in Jamovi so you will not get confused. So this is ANOVA. When you click on analysis, you will find ANOVA. And here in non-parametric, you will find one-way ANOVA, Kruskal Wallis. Okay. When you click on this, you will get this type of window. So dependent variables are all your uh, uh, value data. This is all our Rabindic value. You know, and these are path oriented values. You already know that there is goal and there is path. 14 values are there in path, and this is the data. So dependent variable is self all this 14 value data of path oriented value. And grouping variable में nationality code. So nationality में we have Indian data and Bangladesh data. So this is the result. You will see the p value, df, x2 thing is there. Okay.
That means
There's no significant.
there is no significant difference between Bangladesh and India with respect to the Rabindric
Value.
value orientation.
Path oriented. Yeah. Correct. Because when you let me show you why this is there. When you click on nationality codes, you want to check the N. So you will see N is total. We have 89 data, and suppose I want to see how many one is there and how many two. So, or let me check this thing. Okay. अभी तो ये नहीं आ रहा है नेशनैलिटी कोड आई होप ओके कोई नहीं इसमें नहीं दिख रहा है कि कितने बांग्लादेश का डेटा था एंड कितना इंडिया का इट्स ओके
फ्रीक्वेंसी में होगा.
हाँ ये सब फ्रीक्वेंसी टेबल सर
Uh,
ओके
and descriptives, you go to the exploration, there is descriptive, there
यस
is one frequency table,
सर
and you take only the nationality code
हाँ
and the
हाँ
maybe the edu code is split by.
हाँ so you can see that 51 Indian data was there and 38 Bangladesh data was there.
Hmm.
42.7 Bangladesh data and 51 is Indian data.
57
Also
point
counts are 50,
51
57.3%.
frequency
Freak, huh?
percentage is 57.3%.
Point. Yeah. So for this kind of analysis, you have to have big data. Then only you will get a good result. Otherwise, you will get a result like this only. That is my personal suggestion. So this is
So you
it.
can put these variables, your all the values, and split by nationality.
Sure, sir. So let me
You
show you.
uh,
This is all not
split by
related to non-parametric.
you take
We have
all the
just
variables uh, and split by nationality.
so you will see the result like this.
Hmm.
And now you will
And you
see.
will take only not the missing. You remove the missing. You take
Acha,
only the
huh,
median or means and the deviation.
yeah. So you will see.
So this is the advantage of jamovi.
Yeah.
So here you can find out the nationality code 1 and the 2 and what is the how many people are there. That is better. Another one is the mean 16.8, 16.4. So no significant difference. In case of the median also you will get 17 and 17.0. Almost that is uh, no difference at all.
Correct.
Therefore, we do not find any
Huh.
significant differences.
Any significant, yeah. So this is not related to non-parametric. This is just why we are not getting significant difference because of this very reason. So in your thesis, if you are doing your PhD, then you can try all of this in jamovi because it is very easy to get it.
We
So
have published one paper, I think.
yes, sir, yes, sir,
Uh, this
on value.
Bangladesh, India.
Huh, sir, your paper is there. Let me show them the paper also.
Uh,
So paper is there. In Mind Society, it is there.
hmm.
But I think, sir, it is pro environment of pro. It is, sir, pro environmental
Oh, it is
attitude,
pro-environmental attitude,
not
not this,
Ravindric values.
not the Ravindra Paris. Okay. Okay, thank you, Farah.
Thank you, sir. Thank you, students. Thank you, Ashmita.
So I am requesting all of you, please follow the YouTube. Uh, so if you have any problem, and please you inform us so that we can guide you properly. অস্মিতা, আর তো কিছু বলার নেই না?
Yes, sir. না 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 স্যার এখন জয়েনও করেনি।
ঠিক আছে, ওকে। সো
থ্যাংক ইউ ফারা ম্যাম।
হ্যাঁ,
Thank you, Ashmita. Thank you so much.